the author doesn't do this in the book, but I went ahead and did it for you. This is typical of what you'll see. You'll see the geometry and loading of the truss, and then he'll list the elements that he wants. I went ahead and put these little red squiggles on there to help you visualize it. Now, I think a good strategy is to look at zero force members right off the bat and see if you can find it. Are there any places where there's a case 1? Well, there's one at A, but it's got a lot of forces, so that's not it. There's 2 forces at E, but again, a lot of forces. Here's one at H. See, there's 3. 2 are collinear. There's a load. Same thing at F. What about C? What does that mean? Hey, that's case 2. 3 connected, no load, so that means that this one is 0. So by inspection, you get one of them. Zero force member. The force in CG is 0. 1 down, 3 to go. So now I'm going to imagine the cut, the imaginary cut we talk about for the method of sections here. And we're going to look at the left side and we're going to look at the right side and see which one we like. So we'll go left first. So on left I've got 2 forces I have to deal with, and that is a pin. So there'd be 1 reaction there. If I do the right-hand side, I've got 1, 2, 3 forces to deal with, a little bit more, and I've got a pin which has 2 reactions. So I think I'm going to go left. Not a political statement, just a geometric one. So if I do that, I only really need the reaction at A. So I'm going to, again, I'm going to cheat a little bit. I'm going to use my original drawing as my free body diagram. I'm going to assume that I have a reaction in the Y direction at A, also at E. And of course, it's a pin, there would be one in the X direction. But from my strategy that I've already kind of thought through, I don't care about any of these. I just need the reaction at A. What's the fastest way to get the reaction at A? Do I have some forces in the Y direction? No, that gives me one equation and 2 unknowns, but I can sum moments about E. You may hear me say this a few times this semester. We're going to sum moments about the pin, which in this case is E, and we're going to make sure it's in equilibrium. Now, this has a little bit more to keep track of. So see, along the bottom chord, I've got 1, 2, 3 of these 1 kip forces. About E, they're all creating positive moment. So I'm going to collect those. So I'm going to say the force is 1 kip, and then the moment arms are 12 feet, 24 feet, and 36 feet. So that's 1 moment with a 12-foot moment arm, a second moment with a 24, a third with a 36. That takes care of all of these. What about this 500-pound force here? Well, it passes through E, so it creates no moment. But this one over here does. So that would come back as 500 pounds is half a kip, and that has a moment arm of 48 feet. And then finally, my reaction at AY, which creates negative moment, and it also has a reaction of 48 feet. So from all this, I should be able to get my reaction in the Y direction. I think it's going to be 2. I think it's 2 kips. What do you guys think? Two kips? That's all I need. Obviously, you can find EY and EX now, but I don't need them. So just to make you see this easier, I'm going to redraw this this part of this structure. So this is the left side that we were talking about. And on that, I'm going to put my reaction, which I solved for here, which was 2 kips. And then I've got at A an additional half kip load, at H a 1 kip load, nothing at B. Well, I should go ahead and label this as A. And then I'm going to have my forces, so I'll go ahead and assume those to be in tension. So there's GH, there's BC, and there's the force in BG. And while I'm there, I'm going to go ahead and find what the magnitude, the direction of that BG is. It looks like it's 12 feet by 16. If you divide that by 4, you get 3/4. So it's another 3, 4, 5. What else do I need? I guess if you wanted to, you could go ahead and put in some geometry. That's 16 feet. This is 12 feet. I think that's pretty much it. If you look at it carefully, it looks just like the sample problem we just worked, right? Let's look at our 3 unknowns. All 3 of them have an x component, but only BG has a y component. So I can sum forces in the y direction right now and get that. What else can we do? Well, yeah, BC, BG, they pass through B, so I can sum moments about B and probably get GH. And then this one says BG, GH. Although you don't see it, I'll go ahead and kind of dot it in. If I did extend those lines of action, they would pass through point G. So I could also sum moments about G. So that's a good strategy. And again, the order of this is not important. So I'll just kind of reverse the order that we did previously, and I'll start off by summing forces in the y direction. So I've got the y component of BG, that would be 4/5, and it's acting down. So that would be minus 4/5 the force in BG. That's this one down. I've got this 1 kip acting down. I've got this 2 kip acting up. I've got this half acting down. So I should be able to solve for the force in BG. Let's see, that all adds up to a half, 0.675? I'm guessing. Oh, 0.625, sorry, just off by 500. Is it positive or negative? It would be positive. All this adds up to a positive number, right? And then this negative goes to the side, so I got positive on both sides. This would be a positive, right? No?
Yes.
Should be negative? Really? Everybody take out a coin and flip it. See which we get, positive or negative.
Positive.
I think it'll be 50-50. It'll be positive. So it's 0.625, right? And that means it's in tension. So this is in a tension. This is a tension. You might remember in our previous discussion that if you have a truss under gravity load, that if your diagonals point towards the center, it should be in tension. If they point towards the supports, it'll be in compression. If your diagonals point towards the center, that's tension. If they point towards the supports, that's like it's an arch shape and it's more compression. That's only when it's under gravity though. Okay, now we can sum moments about B or G. G. Which one do you guys want to do first? B. I heard somebody say B, so we'll do that. So we'll assume right-hand rule, and we will sum moments about B. So I'm summing moments about B. BC and BG pass through that, no moment. This vertical node here at H also passes through B. So I just have this one unknown here, GH, and GH is creating what kind of moment about B? Positive. So I'll have the force in GH times this moment arm, which is 16. So that's the moment of GH about B. And then I got to deal with these two guys. So the half is creating positive moment. And it has a moment arm of 12. And the 2-kip is creating negative moment. And it also has a moment arm of 12. Now another way to do this is just to add these two together, and you get 1.5 acting up. It'll give you the same resultant moment. However you want to do it. So what do you get? This negative number is bigger than that positive number, so you throw it to the other side. It looks like GH is going to be in tension. So force GH, 1.5, that's 18. 1.125. Only on Tuesday. Now that's going to be positive. So does it make sense that the bottom element, the bottom chord element under gravity load is in tension? Yes, it does. So what do you expect this top chord element BC to be in? Compression. Yes?
Just like briefly, for CD, I don't know even how these zeros are because it says 154.
Well, I'll help you out. I'll do a little joint of C. We can do that, right? So I'll draw C, and let's assume tension in CG and tension in CD and tension in BC. Okay? Let's sum forces in the Y direction. What's in the Y direction? CG. Right? So what does CG equal to? Here. So anytime you see any kind of setup like this where two are collinear, this one is always going to be 0. But it changes if I apply the load here, right? If I put a load here, then it's not equal to 0. It's balanced by whatever the Y component of that load is. So it's got to be unloaded. That's what makes it unique. I'll box that off as kind of an aside here. Okay, so we need to go and probably some moments at G. Could I go another direction? Well, I found BG, right? And I found GH. So I could sum forces in the X direction to get that. What's the disadvantage of that? If I made an error on any one of these, it was wrong. If I sum moments about G, I don't have to incorporate any previous data that I've computed. Because I'm going to get one equation and one unknown. You might find that to be more trouble, but from my mind, I think it's better. So you can sum forces in the X direction, but we're going to sum moments about G. So when I sum moments about G, you can see that B, G, and GH pass through G. They don't create moment. So I just have to worry about BC and these three forces. So looking at BC, what kind of moment does it create about G? Negative. Right? I'm using right-hand rule. So about G, you can see that it's trying to go clockwise. which is negative. So I'll have negative moment created by BC, and its moment arm is the height, which is 16. Then I've got this one kip force acting down about G. What kind of moment is it creating? Counterclockwise, so that's positive. So that's 1 kip times 12 feet. I'm going to run into that, so I'm just going to come underneath. And then I got these two guys. Now we did it before taking them separately, but I think you can see that there's really a resultant force here, or an equivalent force of 1.5 kips acting up. See that? So I'll just save myself a little time, and I'll look at that resultant force acting up. What kind of moment does it create about G? Negative. So I'll have minus 1.5 kips. Its moment arm will be 12. 24. Whoops. 124. Oh, shoot. Ignore the man behind the curtain. There it is. 24. So what is the result for BC? It looks like it's going to be negative. I don't know this one off the top of my head too well, so you guys will have to help me out.
0.375.
That sounds reasonable. Anybody else get 0.375? No confirming head shakes? No? Oh, there's one, but you didn't do anything. You just Rayman to 2. It seems great. No?
Oh.
Did you?
I got 1.5.
You got 1.5.
Negative.
Negative 1.5.
1.5? Really? That's right, 1.5. I just did it in my head. And it's in compression. That part we knew and we liked. All right, so that took 17 minutes. Hey, we went from 25, 20 to 17. Moving along. Moving on up to the east side.